Okay, today we're going to talk about arithmetic and geometric sequences. So if you remember from yesterday, a sequence is just separated by commas. It's a list. An arithmetic sequence is a sequence such that for all n there is a constant d, this is important, variable, such that d is the difference between successive terms. So a sub 1 always will mean the first term in our example, and so the first term would be 2, and d is what is the difference between any two of the terms? 7 minus 2, 12 minus 7, 17 minus 12, they are all 5. So the common difference, d, is 2. And d is known as the common difference. Okay? So it's known as the common difference. So you can take d and you can find it by taking any term and subtracting the one before it. So term 1 before. And then if you subtracted or you actually, let's see what happened here. Oh, you add a sub n minus 1 to both sides, you would get that a sub n is equal to a sub n minus 1, so the previous term, plus d. Okay, so if you took the term and then the one before plus the common difference, so if you take like 12 and that's a sub n, the term before that is 7. 7 plus 5 would equal 12. Okay. Next, consider the sequence 1, 4, 7, 10, 13. Is it arithmetic? It has to be arithmetic if you have a common difference. It has to be the same between each term. So if I add 3, add 3, add 3, add 3, yep, it's going to be the same common difference, so it is arithmetic. The first term is 1, and that common difference is 3. The next example, 2, 4, 8, 16. You could say you're adding 2 and then adding 4 and then adding 8, or you could also say you're multiplying by 2, but you're not adding the same thing. It is not. And a sub 1 is 2, and the common difference, there is not a common difference. The next piece, is it arithmetic? Negative 3, 1, 5, 9, 13. If we look at it, we would add 4, add 4, add 4, add 4. So the common difference is 4. The first term is negative 3, and yes, it is arithmetic. So we would need to be adding the same thing from term to term. So if you look at what's going on here, you're just taking negative 3 plus 4 to get 1, and then 1 plus 4 to get 5, and 5 plus 4 to get 9. What this does is gives us a formula so that we can find a term. Like what if we were asked to find the 100th term of our sequence? Well, I wouldn't want to just sit and have to list them all out. So we can get a formula. So the first term is a sub 1. The second term is comprised of that first term plus the common difference. And then you just keep adding on a common difference each time. So the third term is that first term plus 2 of the common differences. Then I add on another common difference to that previous term. So the fourth term is a sub 1 plus 3 common differences. So a sub 5 would be a sub 1 plus d plus d plus d plus, now we'd add on another common difference to get a sub 1 plus 4 times the common difference. So then when we have an nth term, that would be then a sub n is equal to a sub 1 plus, it's going to be, if it looks like, you know, this was 4d, but you were finding the fifth term, so it is 1 less n minus 1 times d. 4 is 1 less than the term you're finding. 5, you were finding the fifth term, but you did 4d, that's 1 less. So it's a sub 1 plus n minus 1 times d. This is an important formula for this chapter that needs to be memorized. Okay, so there it is again. So it represents the nth term of an arithmetic sequence. Sometimes it is the last term. It can be used in a lot of different places. D is the common difference. A sub 1 is the first term. Okay, so D is the common difference. So we can find any term in the sequence a sub n using a sub 1, and a sub 1 was that first term, D and n. So find the 10th term for the sequence 1, 4, 7, 10, 13. You could probably just kind of keep adding 3. But if it asked for the 100th term, that would be a little harder. So we can use the formula. So you should write out the entire formula. A sub n equals a sub 1 plus n minus 1 times d. We are looking for the 10th term, so n is 10. So a sub 10 would be the 10th term. Our first term is 1, so that goes in for a sub 1. Remember, n was 10, and our common difference is 3. So this is times here. So our 10th term would be 1 plus 9 times 3, or 27 plus 1, which is 28. So that would be the 10th term. Consider the arithmetic sequence, 20, 18, 16, 14. Now the common difference is negative 2, because you're subtracting 2 to get from one term to the next. So it's negative 2. The first term is 20, and if I want to find the 15th term, again, I'm going to write down the formula. A sub n equals a sub 1 plus n minus 1 times d, and we are looking for a sub 15. A sub 1 we know is 20. N is 15, and our common difference was negative 2. Don't leave it the way I just did. Make sure you put parentheses around that because it's multiplication. So a sub 15, or the 15th term, is 20 plus 14 times negative 2, which is, I believe, negative 28. And negative 28 plus 20 is negative 8. So that's the 15th term. Much quicker than actually, I think, figuring it out, especially if it's a larger term value they're looking for. So if you take a look here, the fourth term of an arithmetic sequence is 80, and the 12th term is 32. So I kind of started to list these out. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the fourth term is 80. 1, 2, 3. So this is 80, and this would be a sub 4. And the 12th term is 32. 5, 6, 7, 8, 9, 10, 11, 12. So that's a sub 12. Now, if you look at it like this, and it tells you it's an arithmetic sequence, then that means there's going to be the same common difference between each of the terms. So if we want to use our formula to determine, we don't know the common difference and we do not know the first term. So if we want to use our formula, which is a sub n equals a sub 1 plus n minus 1 times d, then what we have here is, all we know is that a sub 4 is 80 or a sub 12 is 32. There's a couple of different things you can do. One thing you could do is you could adjust the list so that you could just make a sub 1 be 80, and then So let's let, temporarily, we'll let a sub 1 be 80, which would then, so we're going to shift this, okay, just temporarily over to the first term, which is 3 units back. So I'm going to shift this one temporarily to here. They need to have the same distance between them, 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. Yes. So I'm going to let a sub 1 be 80, and I'm going to let 32 go to this term, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So a sub 9 is going to be 32. So I'm just shifting it over temporarily, and I can still find what the true a sub 1 is. This is just temporarily. So now I can use my formula, and I can say a sub 9. Okay, I'm going to use the formula now, so I'm going to circle it in red. So now I can say a sub 9 because I have that one, so therefore I'm going to let n be 9. And I can say a sub 9 is equal to 80 because I shifted that, plus 9 minus 1, and I don't know the common difference. And then that way I don't have two unknowns. I didn't know a sub 1 and I didn't know d. I wouldn't be able to solve that. And one way to do it is you could use systems of equations, but an easier way is just kind of shift the list a little bit. So a sub 9 we're going to replace with 32 because we know it's equal to 32. So we basically get 32 equals 80 plus 8d, and then you're just solving for d. So subtract 80, and I believe that you get negative 48. 10 minus 2 is 8, 7 minus 3 is 4, it's negative, and that equals 8d, and then divide by 8, so d is equal to negative 6. So that's the common difference. D is equal to negative 6. Now I need to determine the first term, the actual first term. So I will set up my formula again. Let's do it in a different color this time. So a sub n equals a sub 1 plus n minus 1 times d. And so in this instance, I believe that I used a sub 4 equals 80. Or you could use a sub 12 equals 32. It doesn't matter. But I need to go back to the original one because I'm looking for a sub 1. Or you could just take negative 6 and subtract it from 80 a couple of times to get to a sub 1. Depends on how long your sequence is. A bunch of different ways to do this. So I'm going to use a sub 4 equals a sub 1. That's what I'm looking for. I know n now is 4. And I now know my new common difference is negative 6. And then I also know that a sub 4 was equal to 80. So I'm really going to do 80 equals a sub 1 plus 3 times negative 6, or negative 18. And then just add 18 to 80, and you get a sub 1 is 98. So if we took 80 and we needed a common difference, you know, we were going back, we could do 80 plus 6. I mean, we could have gone, you know, and gotten that to be 86 plus 6 is 92, and 92 plus 6 is 98, and that was truly our first term. And then, you know, if you now take and do 80 minus 6, this would be 74. 74 minus 6 is 68, minus 6 is 62, minus 6 is 56, minus 6 is 50, minus 6 is 44, minus 6 is 38, minus 6 is 32. So it all checks out. So that's using the formula to find that. There are other ways, but that's using the formula. Then we have arithmetic mean. the arithmetic mean, so the mean of two numbers is the average of the numbers. In an arithmetic sequence, any given term is the average of the term before and after it. Thus, an arithmetic mean can be any term of an arithmetic sequence. So consider the sequence 1, 4, 7, 10, 13. It looks like, again, it's a common difference of 3. 4 is considered the arithmetic mean between 1 and 7. If you take 1 plus 7 and you divide by 2, you get 4, which is the number right in the middle of it. That's what it's talking about. 10 is the arithmetic mean between 7 and 13. If you took 7 plus 13 and divided by 2, you would get 10. There are 3 arithmetic means between 1 and 13. So 4, 7, and 10. And then blank is the arithmetic mean between 13 and 19. So 13 and then 19. So if we took 19 plus 13 and we divide by 2, we get 32 divided by 2, and that's 16. So 16 is the arithmetic mean. All right, then it says to find 4 arithmetic means between 5 and 100. So 5, 1, 2, 3, 4, and 100. So these can, be your sequence. So I could make this a sub 1, 2, 3, 4, 5, and a sub 6, and I could use my formula. And I could say a sub n equals a sub 1 plus n minus 1 times d to find d. And so I could say a sub 6, because I have that, is equal to 5 plus, remember, n is 6, right here. N is 6. So 6 minus 1, and we do not know what d is. And then a sub 6, though, we know is 100, so you can replace that. And 5 plus 5d. So then subtract 5, and you'd have 95 equals 5d, and divide by 5. 95 divided by 5 is 19. So the common difference is 19. And then you could just do 5 plus 19 is 24. 24 plus 19 is 43. 43 plus 19 is 102. And 102 plus 19, I'm sorry, that's 62. Can't read my writing. And then 62 plus 19 is 81. So the answers are 24, 43, 62, and 81. All right, next, geometric sequences. So geometric sequences, if you take a piece of paper, and it's about 3/1000 of a millimeter, and then you folded it, you end up getting kind of like a pattern. So if you do a fold, you'd get like 2 thicknesses of a sheet, and then if you fold it again, you'd get 4. Ask your teacher if you need to see that to visualize it. If you do it again, you'd get 8. 16. In essence, it's like this doubling thing that happens. And so it becomes 2 to the n. So when you end up multiplying and getting from one to the next, that's called a geometric sequence. So this would be 0.003 times 5, 0.003 times 8 times 16, 0.000, or just 1 3 in there, sorry. A 1 0 in there. So 0.003, 0.003 times 32, and this would be 0.003 times 2 to the n. So those sequences are called geometric because you multiply to get from one term to the next. So in order to figure out what you're multiplying by, that is known as the common ratio here. A geometric sequence is a sequence such that for all n there is a constant. Okay? Each term is found by multiplying the previous term by r. R is called the common ratio. So to find a common ratio, you take the term and you divide it by the one before it. Okay? So then a sub n, if you solved this, kind of like cross multiplying, is equal to a sub 1. Well, I guess it's not the same. A sub n is equal to r times a sub 1 times r to the n minus 1. So to obtain that, we can take a look at this. So if you take a value like 1, 2, 4, and 8, you have to take 1 times 2 to get to 2. And then you take that value, which already has the 1 in it, so you take that value times 2. So now you're multiplying by another r. Then you just multiply by another r. And so you end up with getting r times a sub 1, r squared times a sub 1, r cubed times a sub 1. This one you would add on another r times r, a sub 1 equals r to the 4th. So it is 1 less. Okay, so a sub n is going to equal r to the n minus 1 times a sub 1, and we really write that as a sub 1 times r to the n minus 1. This is the formula that you need to know for a geometric to find a term. So some examples: 3, 9, 27, 81. Find r. What would you multiply by? You'd multiply by 3. 2, 10, 50, you'd multiply by 5. So r is 5. Find the 10th term. In that case, use your formula. So a sub n equals a sub 1 times r to the n minus 1. So we need a sub 10. We know a sub 1 is 3. We know r is 3, and it's 10 minus 1. So the 10th term is 3 times 3 to the 9th. So that's 3 times 3 to the 9th you have to do first. So 3 to the 9th is 19,683. Then that times 3 gives you 59,049. Okay? On the next one, find the 10th term. The 10th term is, again, a sub n equals a sub 1 times r to the n minus 1. So it's a sub 10 again equals 2 times 5 to the 10 minus 1. So a sub 10 is 2 times 5 to the 9th now. And so that's equal to 2 times 1,953,125. So 1,953,000. That is 300. I think it's 3,906,250. So they really increase dramatically. Next one, if you want to find r, another way to find r is to take any term and divide it by the previous term. So I could do negative 6 divided by 3, or I could do 12 divided by negative 6. So r is negative 2. Again, a sub 10 equals a sub 1 times negative 2 to the 10 minus 1. So a sub 10 is equal to 3 times negative 2 to the 9th. Now, negative 2 to the 9th is negative 512, and then that times 3 is negative 1,536. All right, next one, if I take and want to find r, I would do 0.1 divided by 1, so r is just 0.1. So I would do a sub n equals a sub 1 times r to the n minus 1. So I'm doing a sub 10 equals 1 times 0.1 to the 9th. So it's really just 0.1 to the 9th. So a sub 10 is 0.1, 2, 3, 4, 5, 6, 7, 8, and 1. There's the 10th term. Okay. It's really just a lot of formulas here. All right, write the first 5 terms of the geometric sequence. So if a sub 1 is 2, I would do 2 times 3 is 6, times 3 is 18, times 3 is 54, times 3 is 162. This one, 1/3 times 2 is 2/3 times 2 is 4/3 times 2 is 8/3 times 2 is 16/3. Remember, you just multiply the numerator because you're multiplying by 2 over 1. All right, a little harder. A sub 3 is 1 and A sub 7 is 9. Find A sub 1 and R. Again, I have 1, 2, 3, 4, 5, 6, 7. I'm going to change this one around a little bit because this one gets a little ugly. Let's make that a 6, and let's make that a 27, okay? So I really don't then need this one. Okay, so I know A sub 3 is 1, and I know A sub 6 is 27. So again, if I just kind of shift these over 2, then I would have temporarily that A sub 1 is equal to 1, and I would have A sub 1, 2, 3, A sub 4 is equal to 27, okay? So if I do that little temporary shift here, then I can use my formula and say A sub n equals A sub 1 times r to the n minus 1. And I can use A sub 1 is 1, okay, so I can use that piece right there. And I can use A sub 4 is 27 to go right in there, okay? So I'm going to erase that so I have some room. All right, so now A sub 4 equals 1 times, I don't know r, 4 minus 1. So now I do know A sub 4 is 27. So I'd go 27 is 1 times r to the third. So now I just have one variable to solve. So I can now say r cubed equals 27 and take the cubed root of both sides. So I would get r is equal to 3. So that's the first thing they want, one of the things they wanted me to find. Now they want me to find A sub 1. So I'm going to go back and use the original ones. So I'm going to rewrite the formula. So A sub n equals A sub 1 times r to the n minus 1. So now I'm going to use, you can use A sub 3 was equal to 1, or A sub 6 is equal to 27. I'll use the A sub 6 is equal to 27. It doesn't matter. So I'm going to go A sub 6 equals, I'm looking for A sub 1, but I now know r is 3, and it's to the 6 minus 1. And I know A sub 6 was 27, so it's 27 equals A sub 1 times 3 to the 5th. And then 3 to the 5th is 243, and then all I'm doing is dividing both sides by 243. So if I take 27 divided by 243 and math bracket, I get 1/9. So A sub 1 is 1/9. So in the original problem, A sub 1 would be 1/9. And then I would have to multiply by 3. So if you multiply that by 3, that's 3/9. 3/9 times 3 is 9/9, which is 1. And then if you take 1 times 3, you get 3. And then 3 times 3 is 9, and then 9 times 3 is 27. So it all works out. All right, last topic here, geometric means. From geometry, in the proportion A over M equals M over B, we say that M is the geometric mean between A and B. Cross multiply, M squared equals AB, or M is equal to the square root of AB. The three values form a geometric sequence, A, M, B. Therefore, every term of a geometric sequence is the geometric mean between the term before and the term after it. So just find the square root of the product of the two terms around it. So find the geometric mean between 4 and 16 would be, all you need to do is take the square root of 4 times 16. That is the square root of 64. So the geometric mean is 8. So it would be 4, 16, and that's the term we're looking for. Well, 4 times 2 is 8, 8 times 2, 16, so it does form a geometric sequence. A little bit harder, find two geometric means between 6 and 750. So 6 and 750, so this is the sequences. So I'm going to make 6, a sub 1, a sub 2, a sub 3, so 750 would be a sub 4. I'm going to write out my formula. A sub n equals a sub 1 times r to the n minus 1. So I have a sub 4, I have a sub 1, r is 4. I'm sorry, I do not know what r is. That's what I'm looking for. I know n is 4, minus 1. I know a sub 4 is 750, though, so 750 equals 6 times r cubed. So divide by 6. 750 divided by 6 is 125. Goes r cubed, and then take the cubed root of 125, and r is equal to 5. So 6 times 5 is 30. Sorry. 6 times 5 is 30, and 30 times 5 is 150. So if you took 6 times 150 and took the square root of that, that would give you 30. If you took 30 times 750 and took the square root, that would give you 150. So the answers are 30 and 150. So you use that formula. All right, that's it. Thanks for hanging in there. Have a good night.